So we'll be solving another problem that I got wrong on the practice GRE that I took around New Year's Day. So this one is problem number 57 out of 66. For each positive integer n, let xn be a real number in the open interval from 0 to 1 over n. Which of the following must be true? So when you realize this, the interval from 0 to 1 over n is constantly decreasing in size. So that means that, well, let's examine each of these claims. The limit as n approaches infinity of xn is equal to 0. Well, I mean, what we know is that xn is forced to be less than 1 over n and greater than 0. 0, well, of course, approaches 0, and 1 over n approaches 0 as n approaches infinity by the Archimedean principle, which means by the squeeze theorem, xn also has to approach 0, which means that 1 is true. So we can cover up this option, I guess. 2. If f is continuous and real valued and defined on 0 to 1, f of x to n is a Cauchy sequence. Well, no. Counterexample, sine of 1 over x. Think about how that acts. I mean, it starts slow, then speeds up until eventually its frequency is extremely fast, which means that there is no particular spot at which sine of 1 over x to the n plus 1 minus sine of 1 over x to the n is less than some number d. I mean, if d is, for example, 0.5, or any number less than 2, then if x to the n is 1, if x sub n is 1 over n plus 1, then sine of 1 over 1 over n plus 1, and then sine of 1 over 1 over n plus 2, the distance between these two is, I mean, what? I think it's 1 over pi. Probably incorrect. But, I mean, if we that's not the definition of a Cauchy sequence, since for a Cauchy sequence, the distance between each consecutive pair of terms, or the distance between two arbitrary pairs of terms, is supposed to approach 0 as n approaches infinity. So 2 is incorrect because we can find some counterexamples. So it looks like we're down to two options, A and C. 3. If G is uniformly continuous and real valued and defined on 0 to 1, the limit as n approaches infinity of G of xn exists. Well, I mean, the limit as n approaches infinity of G of x to the n, xn, is just G of 0. And, well, by the first statement, which we know to be true. And we know that G of 0 must exist because we know it's continuous and real valued from any x is greater than 0, which means that the limit as n approaches infinity from the right side has to exist. And actually, this is not necessarily true. This is not necessarily true, but I'll replace it with this, which is necessarily true. Okay, so 1 and 3 are true, which means we pick C. So that's it. Thank you, everybody, for watching.